بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Section 2.5 Limits that involve infinity. The aim of this section to examine two types of limits which involve infinities. The first one is infinite limit which does not exist, where f(x) goes to plus or minus infinity as x approach to a from left or from right, and limits at infinity when x approach to plus or minus infinity, and the limit here may or may not exist. Let us see the following graph. Here we see that part A, limit of f(x) when x approach to a. If we approach to a from right, the limit goes to infinity, and if we approach to a from left, the limit goes to infinity. So we conclude here limit of f(x) when x approach to a is equal infinity. And for this one, B, limit of f(x) when x approach to a. If we approach to a from right, the limit goes to minus infinity, and if we approach to a from left, the limit also goes to minus infinity. So we conclude that here the limit of f(x) when x approach to a is equal minus infinity. Also here we have another graph. This one is A, limit of f(x) when x approach to a from left. When x approach to a from left, so that means we go to a from the left, the limit goes to infinity. So the limit here is one-sided limit, which is when x approach to a from left, it is equal infinity. The second graph, limit of f(x) when x approach to a from right. So we approach to a from the right, the limit goes to minus infinity. So limit of f(x) when x approach to a from right is equal minus infinity. And the last one, limit of f(x) when x approach to a. We need to see this one from right also and from left. When x approach to a from right, the limit goes to minus infinity, and when x approach to a from left, the limit goes to plus infinity. So here we see that the limit from left is equal infinity, the limit from right is equal minus infinity. All these graphs, the value of the limit when x approach to a either from left or right or from both sides, it is goes to either plus infinity or minus infinity. We call this line x is equal a for all this graph is a vertical asymptote. So now we need to define what's the definition of a vertical asymptote. So a line x is equal a is said to be a vertical asymptote for the graph of a function f if at least one of the 6 following statements are true. Limit of f(x) when x approach to a from left is equal minus infinity, or limit of f(x) when x approach to a from right is equal minus infinity, or limit of f(x) when x approach to a from left is equal infinity, or limit of f(x) when x approach to a from right is equal infinity, or limit of f(x) when x approach to a is minus infinity, or limit of f(x) when x approach to a is equal infinity. So if one of these 6 statements are correct, so we say that the function has a vertical asymptote when x is equal a. And we mean by the vertical asymptote this line, which is x is equal a. We said here it is just from one side, but the function has a vertical asymptote. Here also this function goes to minus infinity from one side, and we call this one is a vertical asymptote. This one has two different limit when x approach to a from right and when x approach to a from left, and we call this one is vertical asymptote. Similarly for these two graphs, x is equal to a is a vertical asymptote. So if you want to find the vertical asymptote, just you need to find the limit where the limit you need to find the limit of a function where the result of the limit is either plus infinity or minus infinity. So this will give you x is equal to a is your vertical asymptote. Now if we have a question say how to obtain the graph of 1 over x minus a power n from the graph of 1 over x or 1 over x squared. So if you have a graph 1 over x, you want to obtain 1 over x minus a power n. Or you have a graph 1 over x squared, you want to obtain 1 over x minus a power n. We'll see for the first one. Here we have the graph of y is equal 1 over x. This is the graph of y is equal 1 over x, where it has a vertical asymptote at x is equal 0. We see from this one, if you want to draw a graph of 1 over x minus a, which is the same graph, just it shifted to the right by a unit. Here we have 1 over x, this one 1 over x minus a. So it is the same graph, but it is shifted to the right by a unit. So we have this graph, we shifted by a units to the right. Now we have this graph 1 over x minus a. Here we have the vertical asymptote is x is equal to 0, where the limit from right is equal infinity, limit from left when x approach to 0 is equal also to minus infinity. So x is equal to 0 is a vertical asymptote. And for this one, also the limit when x approach to a from right it goes to infinity, the limit when x approach to a from left it goes to minus infinity. So we say here limit of 1 over x minus a when x approach to a from left is minus infinity, and limit of 1 over x minus a when x approach to a from right is equal infinity. If you compare the limit of this one and this one when x approach to here from 0, and for this one when x approach to a, where 0 and a are a vertical asymptote, you will see they have the same result. Here when x approach to 0 from right it is equal to infinity, and here when x approach to a from right it is equal infinity. For this one when x approach to 0 from left it goes to minus infinity. For this one when x approach to a from left it goes to minus infinity. يعني نحن عندنا الدالة الأصلية اللي هي 1 over x، نريد نرسم الدالة 1 over x minus a باستخدام الدالة 1 over x. نلاحظ أن هي عبارة عن نفس الدالة بس فيها اللي هي shifting لليمين بال a units. فإذا كان هنا ال x is equal to 0 ال vertical asymptote، بيكون هنا x is equal a is the vertical asymptote. نلاحظ هنا الليمت من اليمين لما ال x approach to 0 is equal to plus infinity. هنا بنفس الطريقة لما ال x approach to a from right it goes to infinity. هنا لما ال x approach to 0 from left the limit goes to minus infinity, and here the limit when x approach to a from left goes to minus infinity. Let us see the function 1 over x squared. Here we have the function 1 over x squared, and this is the graph of our function, and we have a vertical asymptote x is equal to 0 also, because the limit when x approach to 0 from right or left it goes to infinity. And here we have the graph of 1 over x minus a all squared. It is the same graph, just we shifted by a to the right, and we get this function, or we get this graph. We see this function has a vertical asymptote at x is equal to 0, whereas this one has a vertical asymptote at x is equal a. And here we have the limit when x approach to 0 from both sides it goes to infinity, and for this one the limit when x approach to a from both sides goes to infinity. So we conclude limit of 1 over x minus a all squared when x approach to a goes to infinity. So since it is the same function, just it is shifted to the right by a units, it will have the same result when x approach to a, and the vertical asymptote here x is equal to 0, the vertical asymptote here x is equal a. So note that limit of 1 over x minus a power n when x approach to a from left it is equal to minus infinity, and limit of 1 over x minus a power n when x approach to a from right it is equal to infinity for any odd n positive integer. So for n an odd positive integer, the limit when x approach to a from left it is equal to minus infinity, and limit when x approach to a from right it is equal plus infinity for any odd positive integer, and we mean by odd 1, 3, 5, 7, 9, etc. Whereas if you have limit of 1 over x minus a all power n when x approach to a, the result will be infinity from both sides for n an even positive integer. So for an odd positive integer you have two results. When x approach to a from left it is minus infinity, when x approach to a from right it is plus infinity. But for an even positive integer you will get it is equal to infinity from both sides. If we apply this for this rule, 1 over x minus a all squared, this one is positive and it is even integer, and we say for an even integer the limit will be equal infinity, so here that's why we get infinity. For this one here we have the power is equal 1, and it is an odd, so for an odd we said one of them is positive if it is when x approach to a from left it is minus infinity, when x approach to a from right, it will be plus infinity. So here, when x approach to a from left will be minus infinity, when x approach to a from right, it will be plus infinity. So here we have an example. Find the left and the right limit of fx is equal minus 1 over x minus 1 all squared at x approaches 1. So here we mean by left and right limits that x approach to 1 from right and when x approach to 1 from left. If we want to apply the notes, this one, here we need to see what is the power here. Here we have the power is 2. 2 is an integer, which is an even integer. And we said that for an even integer, even positive integer, the limit goes to infinity from both sides. So using the previous note, 2 is an even integer, so limit of minus 1 over x minus 1 all squared. When x approach to 1 from right, we take this negative out, so it will be minus limit of 1 over x minus 1 all squared when x approach to 1 from right. This one is an even integer, so the limit is equal infinity. But here we have negative sign, so it will be minus infinity. Similarly, limit of minus 1 over x minus 1 all squared when x approach to 1 from left, we take this negative out, so it will be minus limit of 1 over x minus 1 all squared when x approach to 1 from left. This one is an even positive integer. The limit is equal to infinity, so minus multiplied by infinity, it will be minus infinity. So the left limit will be equal minus infinity and the right limit will be minus infinity. So limit of fx when x approach to 1 will be equal to minus infinity. Then we have example 2, determine all vertical asymptotes that the graph fx is equal x minus 4 over x squared multiplied by x minus 5 has. We said that the function has a vertical asymptote if the limit is equal to plus or minus infinity. So limit of fx when x approach to a is equal plus or minus infinity. And we see that the limit is equal plus or minus infinity for the rational function if x squared multiplied by x minus 5 is equal 0. So here x squared multiplied by x minus 5 is equal to 0. That means either x is equal 0 or x is equal 5. But we need to check, is the limit when x approach to 0 is equal infinity or minus infinity? And is the limit when x approach to 5, is it plus or minus infinity? Let us see. Limit of fx when x approach to 0, so direct substitution, you will get minus 4 divided by 0 multiplied by minus 5, so minus 4 over 0, which is infinity. So here we get when x approach to 0, the limit goes to infinity. And limit of fx when x approach to 5, so if you replace this x by 5, you will get 5 minus 4 over 5 squared multiplied by 5 minus 5. So here we will divide by 0 also, we'll get also here, it is infinity. So the limit of fx when x approach to 0 is equal infinity. Limit of fx when x approach to infinity it is equal, when x approach to 5 it is equal infinity. So since the limit here infinity, the limit here infinity, we conclude that fx has a vertical asymptote at x is equal 0 and x is equal 5. يعني في المثال هذا نحن قلنا إنه الفانكشن has a vertical asymptote إذا ناتج الليمت عند النقطة يساوي يا إنه بلس infinity أو minus infinity. طبعا هنا بنقول نحن بهذه الطريقة limit of fx when x approach to a is equal plus or minus infinity، أو بما أنها عندنا rational function إذا معناته لو قسمنا على 0 إذا الناتج يا إنه يطلع بلس infinity أو minus infinity. على أساس كذا أو ممكن ناخذ أصفار المقام اللي هي x squared multiplied by x minus 5 is equal to 0. بنحل x is equal to 0 وال x is equal to 5. ما بنوقف عند النقطة هنا لأنه أحيانا إذا كان أصفار المقام نفس الشيء أصفار للبسط، يعني طلعنا مثلا 0 over 0، هنا من الناتج الليمت ما بيكون يساوي اللي هي infinity أو minus infinity، ما دائما أحيانا يطلع لنا قيمة. على أساس كذا بعد ما نطلع أصفار المقام لازم نتأكد من الليمت. إذا الليمت يعطينا بلس أو minus infinity إذا هي vertical asymptote، لكن إذا الناتج الليمت عند النقطة اللي هي عند الأصفار ما يعطينا بلس أو minus infinity إذا نحن نقول إن النقطة ليست a vertical asymptote. هنا طبعا جبنا الليمت يطلع لنا بثنتينتهم infinity إذا we conclude that the function has a vertical asymptote when x is equal to 0 and when x is equal 5.